Hey Dean, hey Gavin, anybody else joining us? They've been working on the AP multiple choice practice for the first few minutes of class and listening to Moana. If you guys want to join in, go ahead and pause this video, try the 4 problems, and then play it again once you have attempts, okay? Here we go. Alright, set?
No. Alright, that takes work as well. Taking out my calculator. Also, you can't do that because there's 3 variables. So you can't just calculate.
Oh, wait. Oh.
What?
How do you guys feel about this equation of a tangent line of a parameterized curve? Because don't you have to go find your y before you can plug in y1? So what's negative 1 plus sine of 0?
Oh, wait. The equation for x.
What's 0 minus cosine of 0?
That's okay.
What's y prime? Let's do x prime first, because that's easier. That'd be 1 plus sine of t, right? And y prime would be cosine of t. And remember, dy dx of a parametric curve is y prime over x prime. So cosine of 0 is 1, right, for y prime of 0. And sine of 0 is 1 plus, or sorry, sine of 0 is 0 plus 1 is 1. So my final equation would be y equals x.
I did the wrong thing on the right answer.
And then number 75. Did you get rid of t, John?
No, I forgot to do over x prime over 0.
Oh, but you were lucky because it was, yeah. Because it was just 1. And then at which of the t values is dy dx 0? Wouldn't we have had to have set cosine of t all over 1 plus sine of t equal to 0? But wait a minute, hold on. Will the bottom ever make 0? So technically, isn't it just setting the top equal to 0 or multiplying and picking that away and saying, hey, so when does cosine equal 0? Doesn't cosine equal 0 every pi over 2 plus pi n? It's only pi over 2 plus pi n. I see, you see. Dun, 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 dun.
I thought sine t equals negative 1.
But that would make it undefined. It being the derivative. So I'm not looking for undefined, I'm looking for 0.
Wait, I thought, alright, so the denominator equals 0, which makes it undefined.
But that would be a different question. So if they were asking when the tangent line was vertical, or when the derivative was undefined, then I would set the bottom equal to 0. But since they're asking when the derivative equals 0 when there's a horizontal tangent line, I'm setting the top equal to 0.
Oh, you're at the top.
Does that make sense? Yeah. Horizontal, not vertical. Yeah.
How did you set up 73?
73? Haha. Can I show you the way that I did yesterday? Sure. Okay, if I did it, thanks, John. If I did it the way I did yesterday, I would say that f is equal to u squared, u is equal to cosine of v, v is equal to x cubed plus x squared. So then my derivative is equal to 2, hey guys, super nice if you don't talk over me, times negative sine of v times v prime is 3x squared plus 2x. And so my final answer would be, changing everything back, that would be 2 cosine v with a negative sine v with 3x squared plus 2x. And all I need to do is go ahead and get that x cubed plus x squared in. And this is the only one that has the cosine and the sine and the negative 2 and the final little u. Because remember, don't get tricked by the trig notation. Trig notation, I have to think about this as a cosine of x cubed plus x squared all squared. So that's my u squared, then my cosine, then my Anything else you guys want me to go over?
Like our like teaching how to be that is really helpful because
It,
connecting with that, just putting it all in favor of what you're doing, and at the end just like plug it in.
Because it's literally just like boom, 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 right?
Yeah.
And it's decomposition of functions. The only dilemma then, David, is those AP multiple choice where they give you something like right, and then it's like x equals like 0, 1, 2, 3, 4, and it gets crazy, you know what I'm talking about? And then they want you to do something like find the derivative. They don't even say that. They say something like let g of x, no, let h of x equal f of g of x, and then they want you to find like h prime of 3 or something, right? So then it's something where you need to know that form of the chain rule to be f prime of g of 3 times g prime of 3. You have to be able to look up in your table. Oops. So, I don't know. I mean, if I get them the chain rule really down well, and then I introduce this notation, see, that's always my dilemma. Because I'm like, I know that AP is going to ask this of them, but you guys also know that these like weird ones, like number 74 or 73, are really tricky. Like, Adam told my kid yesterday, he was like, when do I learn the chain rule? It's coming, just wait. But no, I think I agree with you, right? I think it's simpler. And even Janelle, you said yesterday, it's easier on your brain. So if I teach it to them this way, do you guys hear that speaker? I'm so sorry, that's annoying. It doesn't. Let me get that off. Maybe if I teach it to them this way, and they get that feel for always having like a times prime, right? It really is peeling it off, and maybe they'd be okay to then go harder. Did it turn off? Okay. But thanks, David. Yeah, I think so too. I should just embrace change and go for it this year, huh? But if you guys are helping AB kids and they're doing that, you'll know what they're doing, yeah? Okay, so let's think together really quickly though. So if I do teach this to them, just because you guys learned it the other way, you're able to do functions the other way. Can we revisit that one that we saw yesterday real quick where I'm not exactly sure how to use this notation? So what if I was to give you one like, find the derivative we could even do something like this of 2x plus 1 times 3x minus 1 to the 4th power. You guys see the dilemma? Now the nice thing is this isn't like the first thing you see with chain rule. So once again, maybe I could expand it. But how could we break this down? Here's what I'm thinking. No, go ahead. What do you guys think? They've already learned the product rule. I haven't made that one weird, like f prime g plus g prime f. So then if we were to do it that way, then I can do, okay, f is equal to 2x plus 1, g is equal to, can I do e to the 4th, right? And then u is equal to 3x minus 1. So would they be able to do second, d first plus first, d second? And then in doing that, right? I mean, you could, because then for your g, you would have u to the 4th instead, right? Times f prime plus f would be 2x plus 1 times g prime would be 4u cubed times 3, right? So they would do 4u cubed and then times 3, and then it's just one thing. I don't know. It starts to get messy out there. But there again, they'll be right. They'll be right if they plug it in. They just won't necessarily have the full answer in their mind before. But wait, hold on. Couldn't this maybe be easier? Because do you guys remember the green? Was it the green little strip?
Yeah.
Green, right? The green line? Why am I going to grab out green? right? Can we pull out a 2u cubed? What's left? U plus 2, 6, right? 6 times 2x plus 1. Got that? We took away u cubed and the 2, and then we took away 2, so that's 2 times 3 is 6, and that's gone, and 2x plus 1 remains. And then at some point you have to plug back in, but at least you have everything all ready to go. So then you would have your 2u, which is 3x minus 1 cubed, and then you would have your 3x minus 1 plus 12x plus 6. And hopefully you would know to simplify that to be 15x plus 5, right? And hopefully then you could pull out a 5 if you needed to, yeah? Maybe that would make that type easier. Huh. Okay, so then what if I gave you something like, this is the one that we saw yesterday, didn't we, that it was nasty? What if I gave you something like sine of 2x cosine of 3x? I think it'd be an f and g again, right? And f would have a u and g would have a v. So you could say f is equal to sine of u, g is equal to cosine of v. I guess that works. And I will have done f and g notation with the product of the quotient rule. Yeah, Janelle.
You could still do like just the product rule if you wanted to, and like break it up into separate like chain rules or something too.
Oh, that's true. Like not necessarily have all the notation-y stuff right away. So I could do like second, because some of them will be doing the box thing, right? Like some of you guys liked that last year. Or just the second and first, just with the words. So second D. So here's the dilemma though. So I guess I could get them to actually showing the D. Taking the derivative. Yeah. First. So then he could be f is sine of u and u is 2x. I could just do that. But then that's nasty because then the f's and g's. Anyway. If any of you guys think of any other way of going about it, I think the f and g might be the easiest one, and for those kids that do it the first and the second and the second and the first, the box and the triangle. I'll talk to them about the outer and the inner, but maybe not the first or second or third day of chain rule. Maybe I'll do that later. Anyway, how many of you guys did in some way, shape, or form use the idea of UVW last night? 1, 2, 3. Okay, 3-ish. So it's a curiosity. I'm curious to see. I don't want to mess them up this year, but like David and Janelle both like voiced yesterday and today, it does make it easier on your brains in some ways. And for some of my CalcAB kids, I mean last year too, some people would have benefited by it. And this year I think for sure some will benefit. It's just whether or not they'll be ready for the AP questions when they come. But you know me, I'll eventually show it to them. Kiddos, yesterday we talked about the parametric equations, right, and the derivatives of parametric. What's the one thing I think maybe I should add, which is going to be your endeavor number 2? Where is he? Here he is. I think we should add an equation of a tangent line to a parametric curve, yeah? I think we should add that. So let's go ahead and make the endeavor card. That was kind of the discovery. Let's not make that our endeavor card. Let's come over here. Is this, do you know wherever he is? Is this? Nope. Sorry, we're having too much fun. Here we go. This guy. This guy. So we have derivatives of parametric equations. I'm tempted to make them 2 separate cards. We have plenty of endeavors. think I can. Trying to see if there's anything else that I want to put on the other card. There's a lot of parametric stuff coming. It's just at the very end of the year, so I don't want to do all of it right now. Nope, not Phil. Nope. I didn't want that. Go away. Is there a third or is there a second?
You said you would make this one two separate ones, right?
Well, that's what I was thinking, but now I might just make it one. So I don't think you need two.
You're trolling.
Wait, I don't know. This is their second.
I knew when I was doing it.
What?
And then we'll do. So I only have Endeavor number 1 up there. Does it mean that I might not have skipped something? I don't remember doing another Endeavor. Hold on. At t equals c. Does that make sense? Because we're not given an x value, we're given a t value. And then we're able to do y of c equals y prime of c all over x prime of c, x minus x of c. Yeah, that makes sense, right? First derivative, second derivative, and then equation of tangent line. First derivative, second derivative, and then equation of tangent line. Let me freeze it real quick. I'm going to make it prettier. Did anybody find an Endeavor number 2? Okay, I didn't think I did one. There we go. Oops, not equations, equation. Okay, that's better. Okay, Endeavor number 2. Some of you might be pondering, ooh, and we also reviewed polar. I wonder if this is similar to polar curves as far as slopes of tangent lines to polar curves. Huh. And equations of tangent lines to polar curves. Except with polar, it wouldn't be t equals. You guys know what it would be? Theta equals. And it would be y prime of theta over x prime of theta. But hold on, wait a minute. We don't get x's and y's in polar. Don't we get r's?
Yeah.
Oh, but we can make x and we can make y with r cosine theta and r sine of theta. Ooh, that's messy. All right, with that, we're going to implicit differentiation. Hey, I alluded to implicit differentiation yesterday. Did you guys catch it? I heard you starting to hear about it. I did. I was referring to the nasty examples of implicit differentiation that you guys like to miss. Now, you guys are just setting up your notes and then we're going to go find somewhere. Set up the first page of notes. Set up the first page of notes. I'm just writing down the time when implicit gets hard. If you guys get bored at any point during class today, you can see if you can solve that problem and do it correctly and perfectly. All right, we're going to grade homework, so as soon as you have notes ready to go, Stick that pencil in that comp book, shut it up, and get out your color pen for us to see where chain rule got you. Whoever reminded me about homework, thank you. I was totally just going to keep going, wondering why on earth we had so much extra time. Whoop. Where are we? 4.1? Yeah. Oh man, number 16 takes up like half the page. Oh, Joe Tan, I have your calculator, I think.
Oh, yes, you do.
You guys want to pass it over?
Thank you.
Okay.
I
He's having too much fun. You guys ready? All right, let's go grade. Section 4.1. I need my remote to open it up. Or unfreeze. That's the soundtrack I haven't listened to in a while. You should bring Let It Go back. All right. So in this one, so if I were you guys using that new notation, I would have had F and I would have had G being U to the fourth. I don't know if that works, but if you guys can remember U prime, then you wouldn't necessarily have to worry about notation on this guy. Because he's just a simple U to the fourth anyway. So 4U, 3 times U prime. But then you do first. Hey! Isn't that a lot like what we just did?
Yes.
Did you stop? Were you a lazy bum, or did you realize exactly what the AP would have asked of you to do, which was factor out and simplify? But these are the ones you guys keep missed. You have missed. You kept missing last year. You're welcome. Because they factor out the common factors, the green rule trick, or the green line trick, or whatever. Oh, it wasn't green rule. Green pen? Green?
The factor trick.
Green trick? Green line trick?
I don't think it was green.
The GF trick?
I think you said trick. Did you say trick?
Green trick? Maybe it's just a green
I
trick.
didn't see it. Wait, what is it?
Or just green line.
Is it green something? Yeah, that's what I thought.
Anyway. GCF. The green GCF trick. Anyway. The point was, could you have made that match that? Because it looks so different. There's no 14, there's no 15, but you gotta pull out everything in common and simplify the rest. That's important. Write down that final answer if you don't have it. That one's important for making it match. They're not gonna ask you this on an FRQ. Okay, number 24. The U could have been U to the 1/2, and then V could have been tangent, and then W could have been 5x. I like this form probably the best, but I suppose you could have done that one. What else? What else? What else? I'm ready. You ready? Yeah. Okay, I thought someone said wait. Sorry. Number 26. Oh! Speaking of polar curves, you guys see them? Look at that little r of theta. Look at that cute little r of theta. This one some of you saw. Secant U, tangent U. Yay! I can write down secant with a 1/2. That's called integration. We're not doing it. They have used product rule. Second D first plus first D second. You don't forget your U primes, which is why there are little twos in multiple places. Could you have rewritten this? Did they try to simplify and did it make it easier? What did those of you that tried to simplify see? And a 2, right? What would have been left? Oh, sorry, 2 theta. Secant squared 2 theta plus tangent squared 2 theta. All all of you who are thinking, isn't that, I love that you're thinking it, but you don't need to ask me. Go find it. We did it yesterday. How do you go find the property that you need? What's the one that everyone knows? Stop being lazy and just go do it. So wouldn't that be, right? Get your tangent by dividing everybody. There you go. Sine over cosines, tangents. Now we have our tangent squared. Plus 1 equals secant squared. What would that be? Minus. So wouldn't you have to look at all of your answers? Yeah, it's 2 theta, thank you. Wouldn't you have to look at all of your answers and see if they got it to be like just tangent squareds or got it just to be secant squareds, right? They could have. They could have substituted this to be secant squared 2 theta, minus 1. Or they could have changed this guy to be tangent squared of 2 theta plus 1. Like they could have played around with it and gotten like a 2 tangent squared 2 theta plus 1 or a 2 secant squared 2 theta minus 1. They could have. I don't know. Just be aware. Is that okay? Mm-hmm. Just be aware. Number 36. Let me get rid of that. Final answer is 5 pi. But there was some nastiness in between. Oh, that's funny. That's gross. You guys get to 5 pi? Yeah. If you did, stand up and give someone a high five. Who got the 5 pi? Stand up, stand up, stand up, stand up, stand up. Good, you too? Good job, stand up. Good job. Nice.
No one in my area, so you know.
Good job.
Sorry, my bad.
I should do better next time, Christina.
Oh, we just recorded that one. All right, so number 44. How is that trig? You guys rocking it? What? You're defining cosecants? Oh, it's okay. It's just 1 over sine. They didn't rationalize. They just took it to the man. Could have been root 3 over 3, but that's no fun. Could have been 1 over root 3 over 2, but that's no fun. Could have been 2 root 3 over 3, but that's no fun. Could have gotten y equals mx plus b, but ain't nobody want to do that.
Isn't there like a rule that like you can't have a square root?
More of a suggested form that we pretend is required for younger classes. To let them know that if they are fully simplifying their answer, they should probably rationalize the denominator. You know. In calculus, we kind of transcend the rules a little bit. Not all rules. Some rules. Don't want you guys walking out of here being like, we're above the rules. No, you're not. 58, you guys got a bit to check, right? Letter A should be 1. You're welcome. Letter B should be 6. Letter C should be 1. And letter D should be, oh, there's a lot. Are you guys grading these? A is 1, B is 6, C is 1, D is negative 1/9, E is negative 40/3. Don't die. F is negative 6. F is negative 6. G is negative 4/9. Whew, and then we made it. That was a good problem. I like that one. What was given to you in that one? Was it functions or tables or graphs or? Yeah, it was. Why did I give it to you? The AP loves tables. Questions on homework? Which one? 36? If you are totally bored right now, couldn't you be opening up Google Classroom, figuring out the homework tonight on implicit differentiation? Sure. Number 36. You were supposed to do f prime times u prime times 1/4. Yeah? F prime times u prime at 1/4. So then f prime, I guess you could have taken the derivative using quotient rule as was. Sorry, my computer's being dumb and my snipping tool is not appearing. I guess you could have done the quotient rule, top being 1, bottom being cosine squared, but that's gross. You could have done a power rule with cosine to the negative 2. Or you could have rewritten 1 over cosine squared to be secant squared. Does anybody remember off the top of their head how they tackled f prime for number 36? Quotient rule, power rule, or secant squared?
I think I turned one of the cosine
Negative 2. Oh, secant squared. So if you rewrite that. F prime would have been 1 plus, we would have had to bring down the 2 and keep the secant and then times secant tangent. But you're not done yet until you get the u prime in there, and the u prime is pi. And all of that is when x is 1/4. So the problem is we need to get the u's out of there and the x's in. So that'd be 1 plus 2 times secant squared of pi x. That's who u is. Times tangent of pi x times pi. We are going to plug in plug in x in just a second, but I'm looking at my secant squared, 1 over cosine squared, tangent is sine over cosine. And I'm not sure it really makes life too much easier, but in my brain, I do kind of like sines and cosines better. So I think I'm going to make this sine of pi over 4, plugging in my x, all over cosine cubed of pi over 4. Because I have 1 over cosine squared times sine over cosine. Pi over 4s are kind of nice because those are all root 2 over 2s, right? I'm going to move my pi in front just because why not? Can I get my root 2 over 2 all over my root 2 over 2 cubed? Should be the same thing as 1 plus 2 pi times, it's the easiest way to show this. Let's just do root 2 over 2 times the reciprocal of 2 cubed over root 2 cubed. I don't know if that's the easiest one, but in my mind it's like a fraction over a fraction, just flip it. And then I can reduce one of those 2's with one of those. I can reduce the root 2 with one of those. I end up with 1 plus 2 pi times 4 over root 2 squared is just 2. And that's going to be 2. Oh, times u prime. Did I seriously do that this whole time? That's ridiculous. Sorry. That should have been a pi. The pi should have distributed. Sorry. My bad. There you go. And then 4 pi plus 1 pi is 5 pi. That got messy because I couldn't scroll. Sorry. But I don't know if that's the easiest way. Maybe it would have been better to get secant and square it and get tangent and then simplify that way. Because tangent of pi over 4 is just 1. That might have been easier. This is probably the harder way because this is the way the book went. Might have been easier just to go tangent. Sorry, kid. But it does work. Anybody else? Something from homework? Lainey?
65.
65. Ooh, falling meteorite. These are so much more fun than last year. Where's the falling meteorite? The velocity of a heavy meteorite entering Earth's atmosphere is inversely proportional to, oh my goodness, do you guys know what we're doing in pre-cal? Go look at the backboard. Math models. Math models. Back in the day it was direct variation, inverse variation. Let's translate. Why am I saying that? You have to make your own equation. Velocity is inversely proportional to the square root of s, when s is the kilometers from the Earth's center. Show the meteorite's acceleration is inversely proportional to s squared. So I would have rewritten this as v is equal to ks negative 1/2. Acceleration is equal to the derivative in terms of s, right? Because s is my independent. So I could have brought down my negative 1/2 power, inversely proportional when it's s powers, and that would have gotten my negative k all over 2s to the negative 3/2 power.
Not negative, but
Isn't that what I did? Oh, what is s? Oh, s is distance. Times s prime. And who is s prime? Supposed to be finding dds times, my notation is awful. Just wait. It's going to be pretty about 5, 4, 3, 2, 1. Did I get an email about that? Do all the club people leave early for club stuff?
they just told me I have to leave.
Okay. Nice thing is this homework isn't due till Thursday on 4.2 that we didn't really start today. I wasn't really planning to. So then we have negative k over 2 s to the negative 3/2 power, which is a positive in the denominator, times ds dt. Who's ds dt? Oh, duh. Yeah. Thanks. Wow, they wanted to totally mess with your brain. There we go. Because then we have s to the 3/2 and s to the 1/2, and that's s to the 4/2, and s to the 4/2 is s squared, and then we have our 2, and we have our negative k squared, but we still have that inverse relationship of a constant over s squared. So you didn't even necessarily need to do any statement explaining it besides just saying that your acceleration, which is equal to dv dt, which is also equal to d squared s over dt squared, is equal to negative k squared over 2s squared. There's that inverse relationship. That was a good question. No one else was asking that? Just Lainey? Wow. That's a little skeptical. A little skeptical. Alright, anything else in the homework? 58? That's one of those tables one, right? As for your derivative, you would have had your negative 2 times g of 1 plus f of 1 to the negative 3 times u prime. So bring down the negative 2, subtract 1, u prime would have been g prime of 1 plus f prime of 1. Which then I would have just had to come up and identify all of those guys, which would have gotten me negative 2 over g of 1 is negative 4 plus f of 1 is 3 cubed times g prime of 1 is negative 8 thirds plus f prime of 1 is negative 1 third. That would be negative 9 thirds, which would be negative 3, and negative 2 would be 6, and 6 over negative 1 cubed would be negative 6? Did it fast. Is that right? Do you know? 58. Yeah. So they have 58 negative 6? No? Let there not be no corrections. We're supposed to be due today, but we got distracted. So I guess you guys can have a day of grace. Or turn it in because the folder's up here waiting, but I won't take it away. And so, bye guys.
Thank you, guys. We love you.
Oh, Kevin, you do 13.
Oh, just turn it in later.
That's the one I
Okay, wait. I don't. Me and Joe got negative 6. Oh, I forgot to plug in. I got -4. Did you see this test?
I'll do it.
No, it's just.
Who gave thumbs up? Daniela.
So if I plug in 1, okay, 2, 8, I want to see what it is.
I just want to do my tutoring job. What am I creating?
The back staple should be good, right?
Yeah.
The one about the island.
Oh no.
Do you guys get that y equals 1 and x equals 1?
Yeah.
So then dy dx.
I got a dy dx equals
-3.
Oh, you put it in right there. Never mind. I think you did it wrong.
Well, I'm doing it like a weird way just to sort of plug in. -6 + 2 is -4. I got 3 to Taurus.
Oh, God. I got what?
Oh, I got positive 4.
I got 6 is -4. -6 and 2 is -4. Oh no, positive 4. Positive 4.
Yeah!
Positive 4.
Can I get like a cookie or something?
Yeah, I forgot to add the 4 to it.
I'm so proud of myself.
Maple cookie.
No, I'm good.
Oh, I don't know.
And cookies? Good.
Maple cookie. Oh. Back by my fridge. Go grab one. See him? Right down on the ground. The box of maple cookies. Yeah.